Alrighty, this is going to be a pretty short lecture. Then what we'll do is bring it to a close, and anybody who has questions about homework, since it's at the end of the semester, you may have, or if you're working on your project and you're stuck, then I can take a look at that and offer suggestions as well. Won't write it for you, but can give you hints. Also, if you upload it and I find something wrong with it, right, then I'll let you know, and you can revise it, send it back. Obviously, that's all for the people who are sitting right here in front of me. Can't help you over the YouTube video, but you know how to get a hold of me. All right, so pretty much we're going to do a review for the exam. The exam's going to be shorter than the midterm, and it took some people like two and a half hours to do it. That was not my intention. Basically, it's just going to be a recap of stuff that we've already done. A few points I want to make. Are there any points? Yeah, sure. I just want to demonstrate a little snippet of code. Say you wanted to, say you had a string like this. And then say you had a list like this. Not a list, another string. I'm just going to repeat some numbers here. So since I like those numbers, 3, 5, 7, what I want to do is I want to print everything that's in this string that matches that. But if I don't see these, like if 1 is not in the list, I'm going to replace it with an asterisk. But I really don't want to call replace because that would mess up the original data, right? Because I could do replace all 1s with asterisks, replace all 2s, dot replace 3, comma asterisk, stuff like that, because that would work. But I don't want to do it this way. So something like if S, how about we do it in a loop? For CH and S, firstly, let's just make sure that works. We're going to print out every character in it, just to make sure that works. I have no idea which lecture we're on.
Are you recording?
Yes, sir. Thank you for reminding me because it's possible for me to skip. Okay, so this would be Z2. Or, some Greek letters, lambda or something like that. We're going to go with Z2. All right. I just want to make sure I know how to print every letter in the string. And it's the same way that I would do it if this were a list. And it looks like it did. It looked like it printed out all the numbers in it. So, what if I wanted to replace every number that was not in our, well, how do we check to see if that character is in the valid string? We would do this. If CH invalid, not invalid is not valid. If CH is in the valid string, great. We could print it out or something like that. I'm going to kind of, I don't know, just to have a placeholder there. Else, it's not in the string. If it's not in the string, okay, one thing I could do, and this is not going to be my final answer because it destroys the string as we go through it, is replace every character that is not found in the valid string with, an asterisk or something, underscore, something like that. And then at the end of all this, I could print S just to see what it looked like after we had modified it. So hopefully you see what we're doing. We're just stepping through it. First character is in our valid string. Great. Don't do anything. Else, replace it, every occurrence of it, with an asterisk. So that would replace, 1 is not in the valid string. So that would not happen. Instead, it's going to replace every 1 with asterisks. and then every 2. But 3 is, so it wouldn't do anything. It'll print found. We're going to tweak this a little bit more. Okay, so, it found some, it didn't find some. The ones that it didn't find were, oh, well, what do you know? It didn't replace them with asterisks because I forgot to store the result in the string. I would have to do this. S is equal to S dot replace, right? Because not only am I going to, I have to store the results of the replace statement, because what this does is it produces a new string. It doesn't change the string. That's true of all of these string methods. If I call string.upper, it doesn't convert that string to uppercase. Instead, it makes a new string with all the letters uppercased. So this did the replace, but it didn't store it anywhere. So I have to do that. Now when I run it, I will see there, right? Everything that's not a 3, 5, or a 7 has been replaced with a star. But like I said, I don't want to wipe out the original string. I might want to use it again, right? So here's what I'm going to do. I'm going to create a display string. For one thing, I'm not going to print it out as I search anymore. But I'm going to call my string, I'm going to build a display string. And the display string is going to have the letter if it's found, but if it's not, it's going to have an asterisk. I'm not going to be calling s.replace. I'm not going to be printing found anymore. So I'm going to make 2 changes there. That change. That change. All right. If that letter is in the valid string, I want to append it to the display string. Append to display string. Now in this particular language, here's how you append it. You can just do display plus equals character. Else I'm going to append an asterisk. Display plus equals an asterisk. And then instead of printing S, well, I guess I could, but the next thing I want to do is I want to print the display string. So we're building a brand new string that consists of asterisks or the number itself if that number is found in a valid string. And there we go. Before and after. So I didn't really want to use dot replace. I could, but I didn't. What else could we do to it? We could make it so that it, after it did all that, you could do a replace asterisk with empty, and it would remove them all. Well, let's do that. Let's just remove all the asterisks that we find. Display equals display dot remove every asterisk you find with nothing, empty quotes, quote, quote. And then let's print that one. Excuse me, not remove, dot replace. Just like we were doing before. I don't know why I said remove. Display dot replace, parentheses, asterisk, comma, empty string. All right, and there's our string, but all of that invalid data has been stripped from it. This, by the way, is kind of like a hangman game, this part right here. Except we'd be appending underscores, right? And the list of valid, this would actually be the word. And this would be the letters that they've guessed so far, like this. Let's say that our word is, what's a long word? Exceptionally, right? That's the word that we're looking for. And so far, the user has guessed an E and an I and an O. They're being sneaky and guessing vowels. And instead of putting asterisks, we're going to put underscores. And maybe I don't need to do this replace business anymore, so I'm just going to comment that out. You know, somebody would be annoyed if you were displaying hangman, but you didn't put the blanks for them to fill in. Like that. So they guessed an E and an I and an O so far. So that's what the word looks like. And is there more than one way to write a hangman program? Yeah, there is, of course. You could store this stuff in an array. You know, each semester, when I assign, you know, a hangman project, I write it myself. And I've kind of gotten it to a science, but my first few attempts were not nearly as clean as they are now. You know, they converted everything to an array, and I could call dot join to, you know. Anyways. So, hope that makes sense. A lot of y'all have already turned in a project, but if you're still banging on the Hangman game and you're using the notes that I uploaded, you know, the Hangman development kit, then this is the same idea. This is how you append, because people were trying to call string.append parentheses when there is no append method. I was writing it in pseudocode. Like that. Okay. Hope that's useful information. Regardless of. What if we were doing the kind of thing where we wanted to pull all the words out of some text? Like we had a text file that we opened up, you know, and it contained a chapter of a book, and we wanted to print the entire list, everything that was in the book. Or we wanted to create a word count, right? You know, the word the appears 100 times, the word hello appears twice, that kind of thing. So let's do something. This is going to say T for text. Short variable names, you know, lousy. Maybe I'll put the whole word, text is equal to, and let's just put a sentence. Hello, comma, there, exclamation point. This is some text. It is incredible. Is it not? Some say so. All right, this is silly, right? But maybe I'm going to build a dictionary that contains all of these words so that later on I could print the dictionary out, right? You know, and it'd be a count. Now, I'm not going to rewrite that entire code. I've done this before. But I do want to cover a point or two of it. Okay, so I'm going to make a dictionary called words. There are other ways of declaring a dictionary. I forget whether it's curly braces or whatever. And then I'm going to loop through this. Well, I need to turn this into an array. I need to turn this into a list, and we've seen how to do that. Call .split. So, I don't mind messing up our text, but maybe I would rather give it a name like test L or T list, right? Something like that to preserve my original data. So T list is equal to text.split. If you don't specify spaces, or if you don't specify anything, it splits it automatically on spaces, which is a nice enough thing. So I'm going to go ahead and do that. I might want to specify, split it like that. Oh, come on. But then it would treat each space as a separate item. But split is smart enough, and I don't know how it does it, that if you don't specify an argument, it would ignore all the multiple spaces, so it wouldn't matter if it looked like that or like that. Also wouldn't matter if there were tabs. It would leave those out as well. Okay. Firstly, let's print out T-list just to make sure it looks good. So I'm going to print T-list. I always encourage you, when writing code, run early, run often. Don't write 500 lines of code and then run it. Write 5 lines of code and then run it. Okay, this is looking good. Hello, comma, there, comma, this is some text. It is incredible. Is it not? Okay, now I see some stuff that I'm not really digging. What do I mean by that? Maybe I don't want punctuation in my words. Maybe I don't want to see exclamation points and commas and, question marks in my list of words that I output. What could I do? I could go through and replace all of that stuff in every item in the list. Or I could use not replace and change everything in it, right? I could do this. Now I'm going to wind up erasing this, but I could do this. Text is equal to text.replace every exclamation point with, either an empty string or space. How about a space? The reason I say empty string is because if my words look like this, I, exclamation point, love, exclamation point, Python, don't type that, I'm going to delete it. Then if I took those guys out, it would say I love Python, like that. That'd be just one word. Uncool. So I'm not going to replace it with an empty string. Instead, I'm going to replace it with a space, because dot split will handle the spaces, right? Well, this will go some way towards correcting the problem, right? It's going to remove all the exclamation points. There we go. There's still some punctuation. There are commas, there are periods. I could replace each one. What I would recommend doing is looping through our string, replacing every character we find that is not a letter with a space, and do that before we split it. I'm going to delete that. We know how to write a loop that goes through every letter of a string. Now here's what I'm going to do. I'm going to declare a new variable called clean text and just set it equal to text. And why am I doing that? Again, to preserve my original data if I needed it. Right? Because I might use that original data again to do a character frequency count or something like that. So, for ch in text, if ch dot is alpha, and is it uppercase is alpha, or is it just dot alpha? Python is alpha. Yeah, it's just is alpha, all lowercase, like that. If it's an alphabet character, great, don't do anything. But if it is, if it's not an alpha character, then we want to replace every occurrence of it. So as soon as it finds a comma, we're going to call dot replace and replace every comma with a space. So instead of if ch is alpha, how about if not ch is alpha, colon, clean text, clean meaning that we're removing all the punctuation and numbers and everything from it, clean text equals clean text dot replace that character that we found with a space. Now this is slightly silly because it's also at a certain point going to be trying to replace every space with a space. So how about we do this? If it's not a space and it's not an alpha. So if ch dot, so if not ch And we may reword this logic to make it a little bit clearer. But if not ch dot is space, misspelled space, and not an alphabet character, then do a replace. The only reason I'm doing that is because we don't want to keep replacing spaces with spaces. That's a little bit silly. We also don't want to replace tabs with spaces or carriage returns with spaces, slash ends. Could we word this a little bit better? I may just leave it alone. We could combine it. We could put parentheses around it and try to make it look a little bit better. I'm going to leave it alone because I hope that's clear. And if you don't like using the word not, you could do this. If is space equals false and ch alpha equals false. Now, the more programmery way, the more professional way is to leave them with the nots. But that can make it clearer, kind of, right? Okay. Once we're done with that, let's print out the original text and the clean text. Print text, print clean text. All right. Here's what the text looks like. It's got all sorts of punctuation. Here's what the clean text looks like. Now I've made one little error. My words are still based on text, the one with the punctuation, not the clean text. So I'm going to need to change my statement down here to be based on the clean text. So right here, instead of t-list is equal to text.split, we don't care about the text anymore. We care about the clean text. So list is equal to clean text.split. Maybe I'm tired of seeing the text in a clean text, or I'm kind of tired of seeing the list in that format. That's what I'm tired of. We're going to add all this stuff to a dictionary now. The reason I'm adding it to a dictionary is just so that it's unique words only, right? Because that's the way a dictionary works. You can't have two elements in a dictionary that are the same word. Now, in a real life dictionary, you kind of can, but instead it's all, alternate definitions of the same word, unless I guess it's a place name rather than a real word. Polish and polish are completely two different words, so they probably have two different entries in a dictionary. Anyways, so we're going to use a for loop. We're going to step through our t-list, adding a value to our dictionary. I'm just going to set the value 1. I'm not going to do anything fancy and actually do a count. So, for item in t-list, for every item in the t-list, let's add that to our dictionary. And I hope you remember how to do that. Words subscript item, that's our key, is equal to a value. Who cares what the value is at this point? Now let's print our dictionary out. But let's put a comment here. Step through list, adding every element to the dictionary. All right. So, for key in words, we're stepping to the dictionary now. For every key in the words, let's print that word out. Print key. And we could also do print key, comma, and if we were curious about that number after it, words subscript key. But for the purposes we're using here, we're actually not going to want to do that. I'm going to put it in there and run it just to see what our dictionary looks like. All right, and there's our dictionary, all the words. Now see something funny. One more funny thing. Lowercase it and uppercase it are the same, or are two different things. And if I was counting words, I don't necessarily want that to happen. Maybe I'm going to convert everything to lowercase. I could do so before I process it, or I could do it before I insert it into the dictionary. I think I'll do it just before I process it. I think I'm going to make clean text be all lowercase. And then I'm going to take out the thing where we're printing the value of the dictionary. We're only going to print the keys, right? So it's going to be a nice clean list of words. Why am I using a dictionary? Because I only want to see the word once. You know, if they put the word hello 20 times in a row, I just want to see the word hello once in my final output. So before we process before we process our clean text, let's make it all lowercase. So right here, before we do our little bit of printing, clean text equals, well, heck, we could even do it up here. It doesn't matter. But anyways, clean text equals clean text dot lower parentheses in parentheses, right? That turns all of our data into lowercase. This might not be an uncommon thing to do here. Stripping out, you only want the words. You don't want all the special symbols, and you don't want the numbers. You only want the words. That's why you would use a for loop like that. And you don't want to worry about whether something is uppercase or lowercase. All right, and there we go. There's my list. Now these numbers are not right, you know. Some of these words appeared more than once. We'd have to do a little bit more checking to actually, I'm not going to finish this because that would be writing a project for you. We're real close though. Hope that makes sense. For everybody who did not do that particular project, I wanted it to be fresh in your mind because this is, you know, this is programmer. This is, you know, pull your boots on and do some programming. It's making some use of the stuff that we've learned rather than just declare a list of animals, right? You know. If we were going to make this fancy, we'd ask for a file name, we'd open the file, we'd read in a line of text, you know, and we'd have loops and stuff like that. I think this is good enough for an example. Anybody need? Alrighty. Now let's review for the exam. Know how to do this stuff. Is this stuff? Declare a list. And by the way, I'm not going to upload any hints that I make from this, so you better write them down if you care. Oh, you know how to make a list, right? You know how to make a list. If we're going to make a list that's got 4 items in it, and we want to call the list, you know, nums. Nums equals, what do I do next? Square, and then I would have to put the 4 numbers or whatever I want in there, right? Something like that, as simple as that. Declare a list of 4 numbers. The variable is called nums, right? That's what we're going to do. That's what we did there. Know how to loop through a list, printing each element. This ought to be old hat. This is a for loop. There's 2 ways. You could do it by index, or you could do it by value for each loop. I'm not going to even do the index-based loop. So, for, and what do you want to call it? V for value, E for element. Some people use EL. For EL in the nums, print EL. Stuff like that. Now this was actually a quiz question, I think. I don't think it was on the last exam. Maybe it was. How do you print the first and the last elements of a list? What's the index number of the first element? 0. What's the index number of the last element?
-1.
Yeah, -1. And burn it into your brain that that's true only in Python. If you're using Java, C, C++, C#, all sorts of other languages, then you got to calculate the length of the list and subtract 1, right? Because what's the index value of that?
3.
Right. So get the length of the list, subtract 1, and that's the last. But we don't need to do that. We're awesome Python programmers. So you could do it in a long way, store them in temporary variables. You could do it in a short way. Why not just print it in the short way? Nums 0. Num subscript -1. Make sure I get something right. All right. Hey, why'd you do that? All right. Okay. All right. So, write 3 lines of code. First line opens a file named, t.txt. For writing. Second line writes your name to the file. Don't forget to put the /n after it. And then the third line closes the file. All right. I didn't even tell you a file variable name. I could just use the word file then. File equals, how do I open a file? The open command, the file name, and then since I'm opening it for writing, what do I need to do? I could do a W, right. Now if I'm going to write to it, I do file.write. I'm going to put my name. My name is Clint Eastwood. I'm really cool. But I have to put the /n there. Because unlike print, which always goes to the next line unless you use the END parameter on it, .write does not go to the next line, which is a real problem. If you opened a file with Notepad and a line didn't have a /n at the end of it, it wouldn't display the line. Like if the last line in the file didn't have a /n, or if all it consisted of was one line of text without a \n without a line feed, Notepad would show it as being blank. So we want the \n. And how do you close the file? Yeah, file.close parentheses. All righty. If you have the string name equals, quote, Clint Eastwood, write a loop that will print every character in the string or in the name, something like that. Now that one looks remarkably like this one. It's the exact same syntax. Exact same syntax. except you're not going to call it nums, right? And since we're talking about letters, we might use something different than EL. We might use CH for character, something like that. So, for CH in name, print CH, like that. Write a line of code that uses dot replace to change every O to a something else. A Y. It's going to be Clint East, whatever. It's going to turn into Orcish or something in the name. Well, we've seen dot replace. I shouldn't even have to show this to you. Name equals what? Name is equal to name dot what? Dot replace, and what's the first argument? O, because that's what we want to replace. And what are we replacing it with?
Y.
Yep. All right, we're real close to the end here. Write 2 lines of code. First line declares an empty list named L, and the second an empty list named D, except it's not going to be an empty list, it's going to be an empty dictionary. Again, we know how to do this. This is old hat by now, especially since I just showed doing a dictionary. So L is equal to what? Empty list, how do we do that? And honestly, there's 2 ways. But yeah, it's going to be square braces. That works, but why not do that? And D is equal to, I believe a dictionary can be done with curly braces. But since I'd have to check, I'm just going to use the DICT function. Like that.
Where's the curly braces?
It is a curly braces?
Yes.
Yeah. So let's put a comment. You wouldn't have to do this, but you know, D is equal to like that. All right, the last one's going to be tricky. Not that tricky, but we have an example right now. If you have a list of numbers named nums, which I think we did from way up here, use list comprehension to convert every number to a string. 1 line of code. And you could do this with a for loop. You could create an empty list, use a for loop, convert everything to a string. You know, it would take like 3 or 4 lines of code, but we can do it in 1 line of code with list comprehension. What is list comprehension? List comprehension is when you put actually some code between square braces. So something like this. Nums equals the opening of our list comprehension, and we want to convert everything to a string. So string of the value for value in nums. So for every value in nums, convert it to a string. That's how you do that. And all this has to be is whatever kind of function you want. You know, it could be int parentheses, you know, it could be float parentheses, it could be a function you write. And the last question. Write a function, not wrote a function. Write a function named hello that accepts a parameter named x and prints your name that many times, or returns the value 100 times x, you know, something like that. Something like that. All right. So what's a keyword that defines a function?
Def.
Yep. Bigger and deafer. DEF. What's the function name?
X.
Nope, that's the parameter.
Oh.
So it's hello. And what is its parameter?
X.
All right. And all it's going to do is return 100 times x. We could store it in a temporary value and return it like that. We could do r is equal to x times 100, return r. We could. Or we can even do it shorter, right? We could just do return r times 100. Either way is cool. I think that's enough. I think that'd make a good exam. And especially if I kind of limit it to what we covered and you burn this information in your brain and you bring in good notes, or have a text file with these notes in it. I'll make a Dropbox called Notes so that you can upload a file, right? Call Notes to it if you want to have written notes that are easy to search. Handwritten is also great. Okay, so I'm pretty much expecting all of y'all to be here on Thursday. I'm talking to the in-class people at this point. But if you want to take it at the Learning Resource Center instead, you can. You might have multiple reasons for doing that. One is you'd have, far more time. And for y'all watching a lecture, then you would take it at the Learning Resource Center or take it with ProctorU. All right. I hope it's been a good semester. I'm going to stop the recording and ask some questions of the lecture group here. Have a good break.